Hello, everyone. We're going to study today the third part of physical treatment technology knowledge, precipitation theory. First of all, let's look at what precipitation is. Precipitation is a solid substance that can settle in water, under the action of gravity, sinking, thereby separating from water. The precipitation function is mainly used for primary treatment, remove impurities and particulate matter. Second, for secondary processing. For example, the primary sedimentation tank reduce the load of subsequent processing facilities. There is also a secondary sedimentation tank, separation and removal of raw mud and realization of slurry water separation. Third, it is also used for irrigation and sugar oxidation. Stable water quality. Remove eggs or solid particles from water. Let's look at the type of precipitation next. Low concentration of suspended solids, and there is no aggregation between particles. Therefore, during the precipitation process, the shape, size and density of particles remain unchanged. Complete uniform speed independently without interfering with each other. Settlement process. Solid particles in grit chamber, and in the primary sedimentation tank. Initial precipitation belongs to this type. The second type is suspended solids. The concentration is not high either. However, the particulate matter is collided during the sedimentation process, so that they can gather together into larger flock. Therefore, particle size and settling velocity. It increases with the continuation of settling time. Late settling of particles in the primary settling tank, and the sludge in the biochemical treatment is in the secondary sedimentation tank. Initial settlement belongs to this type. Third, stratified subsidence. Stratified subsidence is also group subsidence and regional subsidence, or crowded settlement. The concentration of suspended particulate matter is high. The particles are closer to each other. Then the adsorption force will cause all the particles to gather as a whole, but each remains in the same relative position. Common sinking. At this time, water and particles, a clear muddy water interface is formed between them. The settlement process is this interface. The process of decreasing settlement duration. In biochemical treatment, the later sedimentation of sludge in the secondary sedimentation tank. The primary settlers in the concentration tank belong to this type. Fourth, compression settlement. When the concentration of suspension and suspended solids is very high, the particles come into contact with each other, support each other up and down, under the gravity reuse of upper and lower particles. In the intergranular gap of the lower layer, the water is squeezed out. The relative position of particles keeps approaching. Collectivity of particles is compressed. Then the biochemical sludge is in the secondary sedimentation tank and the thickening tank. Concentration processes all belong to this type. Let's look at the comparison of sedimentation tank types. The concentration of suspended pollutants in free sedimentation tank is low. Solid particles do not collide, have no flocculation characteristics. The characteristics of precipitation process do not change. The size and shape do not adhere to each other. It is mainly used in the early stage of grit chamber and primary sedimentation chamber. Flocculation sedimentation. Its concentration of suspended solids is not high, 50 to 500 milligrams per liter. Then, the particles collide with each other, have condensation characteristics, change the shape of the size, disturb each other. Flocculation and sedimentation often occur in the later stage of coarse pool. Regional precipitation, that is, the sludge concentration is as high as 500 milligrams per liter. Interference with each other. Subsiding lower layer. Particle stratification is mainly in the late stage of two-layer pool. Compression precipitation. Its sludge concentration is relatively high. Contact and support each other. Upward pressure sinking. Compression sedimentation often occurs in sludge thickening tank at the bottom of secondary sedimentation tank. The law of individual free sinking, and intersecting accords with Stokes' formula. Stokes' formula mainly discusses the relationship between settling velocity and settling velocity. Relationship between particle density and its dynamic viscosity. With the increase of particle size, its transaction speed will also increase. Number 2. The longer the settling time, the longer the settling time. Favorable to settlement. Third, settlement experiment. Let's look at two settlement experiments. First, look at the first settling experiment. Stir the sewage evenly. Inject into N sedimentation sheets. The size of the simple diameter is generally 80 mm. The height is 1500 to 2000 mm. Measure the concentration of suspended solids. When C0 is the original concentration of suspended solids, through T1, T2, to Tn. After settling time, from a certain height h of each settling cylinder, respectively, take the same sample and measure its concentration separately. Calculate the precipitation efficiency and precipitation speed U in each precipitation time. Then, one of its precipitation velocities can be calculated. The precipitation rate U is closely related to the removal rate, E. Its precipitation efficiency E is equal to C0 minus C, divided by C times 100%. The second experiment is to stir the sewage evenly and then inject it. N settling cylinders. After TL, T2, Tn time. Take all water samples above H section. Measure the suspended concentrations C1, C2 and Cn in water samples. Then, if the settlement of water UT is greater than U0, the removal rate is taking eta 1. If UT is less than U0, but the removal rate near the sampling surface eta 2, its total removal rate is eta 1 plus eta 2, and then U0 is a certain precipitation rate. P0 is the ratio of particles to the total amount of particles. That is, the residual profit margin P0 of suspended solids. Then for each particle whose UT is less than U0, it is removed. Its removal effect is different. Then the sedimentation curve of flocculation sedimentation is drawn. After the sewage is stirred evenly, inject a sedimentation cylinder with a series of sampling ports. H is 150 to 200 mm. And the height h is 1.5 to 2 meters. Measure the suspended concentration C0. Take a certain amount of sewage at different depths. Measure the concentration of its suspended solids. Finally, the sedimentation efficiency E value is calculated. Here are two graphs of precipitation curve. As we can see, the precipitation curve of 15% is corresponding precipitation time and the concentration change of one of its precipitation heights. Let's look at the sedimentation principle of the ideal sedimentation tank and its effects. A conceptual hypothesis is put forward. First, sewage is in the pool. Constant velocity flow is done in the horizontal direction, and the horizontal velocity v. Outflow time from inlet to outlet. In the inflow zone, particles are uniformly distributed along the cross-section AP. And in a state of free precipitation, the horizontal distribution velocity of particles is equal to the horizontal flow velocity. Third, particles are considered to be removed when they sink to the bottom of the tank. Functional partitions can. It is divided into inflow area, outflow area, sedimentation area, and sludge area. This is the zoning condition of ideal precipitation. Analysis of ideal sedimentation tank. First, after the particles enter the sedimentation area with the water flow, its trajectory is slope. A straight line of U divided by V, in order to completely separate particles with precipitation rate of UO. You can get U0 divided by V equals H divided by L. For particles where U is greater than UO, U divided by V is greater than or equal to H divided by L, so that it can be completely removed. Settlement efficiency is equal to 1 minus P times 100%. For particles where U is less than UO, it is usually carried out of the sedimentation tank by water flow. Part of the particles are completely removed. If the surface area of the sedimentation zone of the sedimentation tank is A, the width of the sink cell is B, treated water flow Q, all corresponding flow velocities are equal to Q divided by A will be divided by A is equal to one of its efficiencies Q0. Q divided by A in the equation is the sedimentation tank. An important parameter of design, called surface load. The unit is cubic meters per square meter per hour. Surface load is a key parameter of sedimentation tank. Surface load Q0 is numerically equal to the precipitation rate U0 of the removed particles. The smaller the surface load Q0 is, on particles with precipitation rate U greater than UO, the greater the proportion of SS suspended solids. The precipitation rate U is less than the medium of UO, the greater the proportion will be removed, the higher the total precipitation efficiency. Surface load has nothing to do with water depth. When the volume of settlement area is constant, the shallower the water depth, the larger the surface area, hence the application of shallow precipitation. Analysis of actual sedimentation tank. In actual sedimentation tank, none of the hypotheses of ideal sedimentation tank exist. Sedimentation velocity of particles, temperature difference, density difference, dead angle in the pool, friction between water and pool wall, water distribution. The precipitating velocity of particles is reduced by the factors, such as water collecting device and so on. Horizontal partial velocity v of water flow may cause the settled particles to be re-washed. Therefore, the standing precipitation curve is used for design time of sedimentation tank. Follow the following empirical formula. Design and surface load Q and precipitation time T0, U0 and 2 are free settlement curves, respectively. One of the corresponding theories found settling velocity and settling time. That's the end of the lesson. Thank you all.